Hi and welcome to yet another organic chemistry lesson, and in this one we're looking at carbonyl derivatives and how to name carbonyl derivative organic molecules. So what is a carbonyl derivative? Well, that would be when we have a functional group where we have a double bonded oxygen to a carbon, which means that that carbon, since he had 4 valence electrons, 2 of them is shared with oxygen, who had 6 valence electrons. So he had 6. Okay, he's sharing 2 of his with oxygen, which means that oxygen now has all 8 of his valence electrons, and now he's got 2 more. Okay, let me write like this. He's got 2 more, and depending on what we have on these two now depending on what we have on these 2 little branches here, or what will look like they're branching off here, is going to depend on what it is called. So for example, I could have just a further carbon chain here. Okay, so I could just bond here with another carbon. Let's write it here. So we could now have this carbon double bonded to an oxygen, bonded to a carbon, bonded to a carbon, bonded whatever, it doesn't matter. But the point is, my one bond is with another carbon, my other bond is a hydrogen, and that's where it stops. Okay, so we have a hydrogen bond on the one side and some substituent on the other side. So this can be any alkyl structure. Okay, so carbons and hydrogen on this side, and this would be called a aldehyde. An aldehyde. Okay, now an aldehyde therefore means that my carbonyl derivative, in other words the carbon double bonded to an oxygen, is almost at the end of my carbon chain, or at the beginning, I suppose, of a carbon chain, because there'd be a carbon chain, and the only other thing bonded to this carbon is a hydrogen. Then it is called an aldehyde. Now the naming convention for aldehydes, all we do is we add an al suffix. So we have a suffix of al. So let me look at the first example. Okay, so we might have carbon double bonded to an oxygen, single bonded to a hydrogen, single bonded to another hydrogen. So instead of bonding to another carbon, and in other words, I will have 2 carbons in my carbon chain. This, I've got 1 carbon in my carbon chain. Point is that the bond that carbon is making has at least 1 hydrogen bond. That would make it an aldehyde. Got at least 1 hydrogen bonded to my carbon, and that would make it a aldehyde. And now this thing is called because there's 1 methanol. Okay, if I had 2 carbons, so I have a carbon double bonded to oxygen, bonded to another carbon, which now is just bonded to 3 hydrogens, and on my carbonyl functional group, this one, I've got at least 1 hydrogen. Now I've got 2, so this is ethanol. Okay, very basic. The rest of this works exactly the same. If there's any branching, I start numbering from my carbonyl branch, and then or from a carbonyl carbon, and then I'll name the branches as I did before. So I'm not going to go into all that. Okay, I'm going to move on to the next carbonyl derivative. Again, carbonyl is when I have a carbon double bonded to an oxygen. But now, if I had my carbon double bonded to an oxygen, and then single bonded to a substituent, just as I had now. In other words, substituent again is a carbon and a hydrocarbon branch. Let's call it that, a hydrocarbon branch. In other words, hydrogens and carbons. And then on the other side, I've got another substituent. So instead of just having a hydrogen, I've got another hydrocarbon branch out here. This is called a ketone. A ketone. Okay, and we add, for this we add the suffix O-N-E. Okay, own. So if we look at an example, the simplest ketone is obviously where I have my carbonyl group there, and then obviously on both sides I can't have a hydrogen on either side, because the moment I have a hydrogen bonded to my carbon, my carbonyl carbon, then it's an aldehyde. So the simplest ketone is a carbon bonded to a carbon bonded to another carbon. Okay, and then that would be the end of these ones, or the end of this chain, and this one would look like this. All of these being hydrogens, I'm not going to write them in. Okay, this one would be, okay, how many carbons are there? 1, 2, 3 carbons. Okay, so there's 3 carbons, and this would be called because there's 3. Propan. Okay, and then we would write the carbon on which we find the carbonyl. Okay, propan 2 own, because on the second carbon, no matter from which side you number, we find our carbonyl group. Okay, propan 2 own, and that is this one's name. Now this one could just be called propanone, because there's no other way in which we can structure this one. So for example, okay, let's say we put the carbonyl group on a different carbon. Let me show you the example. So let's say instead of on the second carbon, it was on the first carbon. So if this first one had it, okay, then there's another carbon. So let's say it was like this. Okay, then this one would be hydrogen. All of a sudden, this is not a ketone anymore. Okay, this is now an aldehyde. This is propanol. Okay, this is propanol. So the only way in which to write propanone, propan-2-one, is propanone. In other words, there's only one way in which it can happen, so you don't have to write that 2, although writing it doesn't make it wrong. Okay, so there we go with the first 2 carbonyl derivatives. The next one is carboxylic acid. Okay, carboxylic acid has a carbon double bonded to an oxygen, okay, bonded to a substituent, and on the other side we have an OH. Okay, now notice that we are our 2 branches, one goes out to be some alkyl group, in other words hydrocarbons, and then the other one is an hydroxyl branch. Okay, hydroxyl branch. This is called a carboxylic acid, which is odd because OH usually denounces a base, which is the opposite of an acid, but these are definitely acids because they donate hydrogens when they react with bases. But anyway, this is called carboxylic acid. You'll learn more about acids in a later lesson. Okay, and for carboxylic acid we use the suffix oic acid. Okay, so let me give you the simplest. Carboxylic acid would be, as an example, would be a carbon double bonded to an oxygen, single bonded to a hydrogen, bonded to OH. Okay, and in this one's name is methanoic acid. Okay, so notice we have our methane and then we add the suffix oic acid, methanoic acid. And if I were to add another carbon, okay, so there I'm adding another carbon and OH, again hydrogens on those ends. This would be ethanoic acid. Okay, and you'll notice that in these cases the carbonyl group, the double bonded oxygen, has to be at the end because there's no other way in which you can have more carbons connected on the other branch. So this is the last carbon, which means that if I were to write a general formula for the molecular formula, I'll always have, or not molecular formula, structural formula, condensed structural formula, I'll have a carbon double bonded to an oxygen, and this thing will still be bonded to OH. So I'll always have this in my structural formula. On this side, for example, I've got a CH3, COOH. Okay, that would always be a methanoic acid if I have this in the end of my condensed structural formula. Let's look at some condensed structural formulas here. Okay, for this one, for methanol, I'll have a condensed structural formula of in the end I'll have my COH. I'll have COH in the end. Okay, in methanol I'll have CO, but it would be somewhere in the middle. Okay, so I'll have a CO, but then on this side I'll have a substituent, and on this side I have a substituent. So somewhere in the middle I've got my carbon oxygen bond. Okay, so the last one we're going to look at is the esters. So an ester has a carbon double bonded to an oxygen, single bonded to a substituent, and then the other bond is again to an oxygen, but instead of this oxygen bonded to a let me just write this ester, instead of this oxygen bonded to a hydrogen, okay, stopping the chain the moment that happens, it is bonded to a substituent. In other words, more carbon and hydrogen bonds. So for esters, we've got this thing going. We've got COO, okay, just like we have here, COO, but instead of COOH, we have COOC and whatever follows on there. Okay, so it can be a whole substituent of carbons and hydrogens, and this is called an ester. So in naming esters, we have a suffix, okay, that we are going to use, and that suffix is going to be O8. Now naming esters is slightly more complex, so in the next video I will look at specifically how to name esters. I'll see you in that video.